I'm just going to move this zoom bar so it's not in the way, like this. Okay, so I am going to talk about Slurm Job Scheduler and MATLAB in the terminal. And I have a connection here on Tetralit and another one to Alvis. So I'm going to use those two to show how to give the various commands. So the idea here is that we will understand and use the Slurm scheduler, configure the cluster, start MATLAB batch jobs from the command line, and then there will be an example for you to try. So now when we are going to use the batch jobs, we will need the project ID. And there are some project IDs listed here. And at the three NAISS systems, Tetralit, Dardel, and Alvis, it is the same project ID. And there are different ones at the three local systems. So which one you will be using depends on which system you have access to. If you're using a different one than the ones listed, you will have to use your own project ID. The same goes for storage space. If you are on one of these 5 systems, there is storage space you can use. Otherwise, you will use your home directory, for instance, on Cosmos LUNARC, because that is a much larger space they have on for the home directory than on the other systems. So, and first, I will repeat what you have probably heard before, that if you're running longer resource-intensive or parallel jobs, you have to run them through a batch script or as an interactive batch job. And that also includes through the Open on Demand, because those also run on compute nodes and after starting a batch job. But we will look more at that later today. So the batch system that is used at most of all of the NAISS systems and most of the Swedish HPC centers is called Slurm. And Slurm is an open source job scheduler. It provides 3 key functions. First, it keeps track of available system resources. So it knows about how many nodes are available, how much memory, how many GPUs, all these kinds of things. And it keeps track of the available system resources. So it keeps track on how many of the nodes are available, how many are allocated, and so on and so forth. It also enforces the local system resource usage and job scheduling policies, and it manages a job queue, distributing the work across resources according to said policies. And the policies varies a little bit depending on centers, but in general, you have a priority, and that can go up and down depending on how much you use the system and at some centers when you submit the job, and also the priority of other users. But in any case, your job goes to a queue and it sits there until it will be allowed to run. Users ask for compute resources in a batch job or with the sbatch command. And if you attended our session yesterday, you know this already, but I'm going to repeat it if you didn't. So to run a batch job, you must create and submit a Slurm submit file. This Slurm submit file is also called a batch submit file, a batch script, or a job script. If you look at it online, then it can have any of these names. And it's unfortunate that so many different names are used for it, but they all refer to the same thing. You can find guides and documentation at each of these centers. MATLAB works well with Slurm, so there are several ways to run MATLAB jobs. And you can use the job scheduler, the batch command inside MATLAB's desktop graphical interface, or inside the MATLAB on the terminal, because there is no difference between that. It is the recommended use to start it from inside of MATLAB. You can also start a parpool with a predefined cluster, and that gives you more interactivity. Or you can write a batch script, just like you can for any other software, and then submit the job with the sbatch command. And that's useful if you have some very long job you want to run and you don't need to modify the code. There are some caveats for parallel jobs where you have to be careful, but it can work. And we do have users that run it this way. So useful commands to the batch system. Before I talk about more MATLAB specifics for batch jobs, I will cover some useful commands for the batch system. There's first the submit job that you do with sbatch and then the job script, whatever name you gave it. Here I have put .sh suffix. It's also common to have .sbatch, but neither is necessary. You can call it what you want. All that matters is that you can easily find it in your job directory or in your directory if you have a lot of files or something. So to get a list of your jobs, you can do that with sq -me. You can substitute -me to -u and your username. How to check on a specific job? You use scontrol show job and the job ID. The job ID you get when you submit the job or from this list of your jobs with SQ. And it gives you some more information. To delete a specific job, you do scancel and the job ID. You can also cancel all your jobs if you find that you made some error and you don't want them to run. So you say scancel -u and your username in that case. And then this command here can give you some more information about a job. For instance, how much memory was used and things like this, which can be useful if your job crashed or something. And you need the job ID, and this output here is very wide. So because of that, you pipe it or send it to another command, which is called less. And then you use the option -S, because that means that the output will be scrollable sideways with the arrow keys on the keyboard. And then there are different ways to get a graphical output of the info about your job. This command here is only for Kebnekaise, but there are similar ones for the other clusters, and I should probably list them, and I need to do that for the future. So, in order to submit jobs to Slurm, you need to configure MATLAB the first time you load a particular version, or at least you do at most of the centers. This configuration step, it gives some default specifications for batch and parallel jobs, and it sets up what is called a cluster profile. The configuration needs only be run once per version of MATLAB on a cluster. But if you change the version of MATLAB, you need to rerun it, so remember that. The specifications can also be changed or added to at runtime, and you can have more than one profile for a release if you need to. And here are links to some information for each of the centers. Note that PDC and C3SE, there you don't need to configure, it is done in a different way there. And on Dardel, as Rebecca mentioned, you either need your own MathWorks account or to contact them ahead of time and ask for access to run MATLAB there. I don't think this line is correct right now because we didn't get a reply back. And but in any case, don't run configure cluster on Dardel. It doesn't do anything, or it's not installed. Yes.
Yeah, that little note on Pele, that turned out not, the error message there turned out not to be related to config cluster. It just didn't work inside the MATLAB GUI.
Okay. Okay, so on Pele, you cannot run config cluster inside. You have to run it on outside on the terminal. Or
Yeah.
what? Okay. Okay, that's good to know. So in most clusters, you can do the configuration in a regular terminal with the config cluster. At some centers, you add the .sh, at some not, and at others, you also have to add the project ID. And it's listed here. Though at Pele, it cannot be done inside the GUI, it only can be done from the terminal. On, let's see, on NSC, you actually need to go into MATLAB to run it. So I'm actually going to do that example here. And I would suggest that if you haven't, you should do the same thing at the center you are working at. So first, I'm going to see which MATLAB versions are available. And I am going to go with this one here because well, maybe I will take that one. So because I'm worried about the newest. But I think that there's something about that you have to take the bdist. Or what did you say, Rebecca? It's better to use the bdist one, or what? At Tetralit.
I think we have said that before, and we have.
Yeah, I think so too,
Yeah.
but I'm not
Oh,
just
sorry, I was muted. The bdist ones, you're supposed to use those, but if you forget the bdist, it'll kind of add it for you.
Okay, that was how it was. Yeah, that's right. That's what you said. Yes. Okay, so anyway, it can be loaded directly. So I'm going to do that. Module load the MATLAB 2024. And we have it loaded. And now I'm going to start MATLAB. And I am going to add these node display splash. And it seems that it also wants the minus software OpenGL at NSC. It will take a little while for it to open. I'm not doing a configuration on Alvis because in there instead you will well you get an allocation where it sets it up on a compute node and that sets up the configuration of the cluster by simply running on what you have allocated. And that is sort of the same way as what is done on Dardel. But now MATLAB started here, and I'm going to do config cluster. And then I get to choose, and since I'm on Tetralit, I should pick that. This looks a little bit different between the centers, but not hugely. I mean, you can see it here. So Yeah, I should probably have added single comp thread as well, but I'm not going to run anything here, so it doesn't matter that much. I was just setting up the profile. So I'm going to exit it again. Because now I have run config cluster. And so I will talk about MATLAB now, because now we have actually configured our cluster. So it knows, so the batch system now will know where to run. And there is a behind the screen that is being loaded about this cluster here now. So there is a configuration file that we are not seeing that is being used to set the things correctly when it's being told that it's tetralit, for instance. So when you start MATLAB on the command line, just like when you started on the GUI, you can do some job settings. You can create a park cluster, and you can set various additional properties, like maybe you're using GPUs or you are using extra CPUs, or maybe you need also to set the project ID and how long you're going to use it, the wall time, things like this, and then start the batch handler. So I'm going to try and do these things. And you can run things in the terminal exactly the same way as you do it on the GUI. There is really no difference. But now when everything here is set up, I'm going to start MATLAB, and this time I'm going to add the single comp thread. So it's not going to eat up all the cores on this node. Not all centers require you to use all of these flags, but adding extra ones should not harm it in this case. So, and Rebecca already mentioned this thing about single comp threads to avoid it starting too many threads. So now you're inside MATLAB, and it looks maybe a little different than it does in the GUI, but you can do exactly the same things. So here, let's try and maybe make a small matrix. As you can see, everything works the same. There's no difference in working. And if you're connecting remotely and you just want to do some things quickly, then it might actually be faster to just run it this way. So everything as normal. So now we know we can use MATLAB on the command line or in a terminal, just like we would on a GUI. But how do we then run it through the batch system? Well, to do that, aside from configuring the cluster, we also need to set some job settings. And those we can set in the command line. And one we need to do is set park cluster. And I'm going to do that here. And this should work. No, sorry. I should replace it to tetralit. You are supposed to put in tetralit here, just like you are supposed to put in Kepner-Kaiser for SPC2N and so on. And then you want to set your project ID. I'm on tetralit. So there it was NAISS 2025 to 934, I think. Yes. It did something. Launching update executable. I don't know what that is. I'm guessing it's something that is running in the background on the MATLAB program that is updating something. I'm going to ignore it. So now we have set the project ID that we are running in. We are also going to set the wall time. And I'm just going to ask for half an hour because I think that's probably enough. And then I will save my profile like this. And if you want to see what you have added here, if you go into it at some later point, then you do see additional properties, and then it will list what you have set. So you can see here you have set the project ID or the account name, and this is the default at Tetradit, and you can see it's set to the wall time. One thing you might want to set at some later point is, for instance, GPUs per node. We'll talk about that on Friday. And constraints could be what type of GPU, for instance, also, or what type of CPU if there are different types. So there are some things here that can be set. And how you do this, it depends on which system you're at. At UPPMAX, I'm not sure if this is still true because when I tested it for Rackham. And maybe it's different on Pelle, but you should use just C equals par cluster instead of C equals par cluster and then the cluster name. On PDC, at least, that is true. Maybe Björn knows.
Yes, only par cluster. Or
Only.
no, I mean config cluster, yes.
Yeah, but when you are inside, you should still do the C equals par cluster, or not? Is it different on Pelle?
No, it should be the same.
Okay, it should be the same. Do you still need to add that you use 20 processors per node? Because I'm assuming that was something that had to do
Yes,
with
one can
Rackham.
increase that to 96, and I'm just about to update the local MATLAB page.
Okay. Yeah, no, I didn't get access to Pelle until yesterday or when it was. So I haven't had time to update it for Pelle. So, but yeah. But I think most is the same as it was for Rackham. On C3SE, the parallel toolbox doesn't allow multi-node jobs. How you do it there is that you start an interactive job on a compute node, or you run it through the open on demand. But I'm actually going to try and do it this way. Copy this here. So what you do here is that you start an interactive job with this project ID. And since this is Alvis, you need to ask for GPUs. So I'm asking for one. And then I'm asking for 1 hour. And then I'm telling it that the job I want to run is just a shell. So I will just open a shell on a compute node. And in that shell, I'm going to open MATLAB. So it will sit here now for a little while and queue for resources. And then when I get resources, I should be able to start MATLAB there. I don't know how long that will take, but maybe I should just continue while I wait for this. And I can mention that, of course, you load MATLAB as you did before, so that should have been added here also. And then you start MATLAB, and then you do C equals par cluster local if you are on Alvis. So we have Dardel as the special case here as well. And there you do not set any additional properties. You work in an interactive session, just like on Alvis. And in order to start an interactive session at PDC, you do you give this command to start the interactive session, either on a full node or on a subset of the course of a node. For instance, here in this example 24. When you do have this job started, it will queue for a little while, just like the one on Elvis does. Then you will do SSH to the compute node. If you need to run the GUI, you should do SSH minus capital X and then the node, or otherwise you just do SSH and the node. Then you load MATLAB just like normal. And I believe MATLAB R2024A-PS is still the one that is accessible even if you haven't emailed them to get access to MATLAB. That one should work. But I don't know if it still does. I tested it a couple of months ago. And back then you could still do so. So if you load that version and then start MATLAB on the command line, then that should go well. You can see this job is still waiting for resources. And this is what I just did on C3SE. And this is how it will look whenever I get my resources. So I load MATLAB and then I start MATLAB the same way as I did here on Tetralit. And then the only setup I do is that I say C equals par cluster and local. I do nothing else. I don't set additional properties because those are carried over from when I started this job on Elvis. And the same is true for PDC. So whatever system you are at, try and start up MATLAB and then do this fill in the job settings with this command here, C equals par cluster, and then cluster will either be Kepner-Kaiser if you're on HPC2N, or UPPMAX, no cluster, just C equals par cluster. In LUNARC, you write Cosmos, and probably this depends on the MATLAB version. I think I was using 2023B when I made this example. Here we say tetralit, like I just did, and well, the others, one is local and one you just say par cluster. So, and since this is a short test, you can just ask for 15 minutes instead of an hour. It doesn't really matter. I asked for 30 minutes here. But when these settings are made, then you can run a job from within the MATLAB terminal interface. Because then when you start batch from inside, it's going to start a batch job, put it into the queue the same way as it would do if you were submitting a batch job on the command line. So here I'm going to make one that I call job. I could write something else here. Job is just the variable I'm using, and I need to run some script here. And I think let's see what's the name of the script I'm using. Yeah, I have the add to one. I can probably use that. Anyway, what you do here is that you take some variable and assign to your batch script. And my script will be your MATLAB script that you're running. And this won't block MATLAB, so you can just continue working with it, do other things just like you do normally. But you can block it if you want to, then you tell it to wait on the job. But you don't need to do that. You can use it meanwhile. And as default, MATLAB saves the command window output to something called a diary of a job, and you can retrieve it with diary job. And remember, job was whatever you call this. And when the job has finished, then you can fetch the result with the load function or the fetch outputs attribute. What you can also do is, while your job is running, you can start another terminal window, and there you can do sq --me, and then you will see that you have a job running, just like if you had another batch job. And if you want to get the MATLAB job ID, then you do id equals job.id within MATLAB. But this here, sq --me on a terminal, that gives you the Slurm job ID, so those two are separate. If you want to see if the job is running inside MATLAB, you do job.state. So you can look at the job both inside MATLAB and outside on a terminal. And so let's see how it is for a specifically serial MATLAB job. So first to set the par cluster, we have already done that. And then you have the command of the MATLAB job. And then the number of output arguments, so you put those if you need that. And then any input arguments is added after that. And J, this job handle, I'm just calling it J here. That's what I called a job further up. You can call it anything. Again, these are how you get information about it and how you delete it. And if you're running a lot of jobs, and if you want to quit MATLAB maybe, and then restart it later, you can actually get your list of jobs again afterwards when you log into MATLAB again. And you do that with jobs equal c.jobs. Then it will give you a list of them, and then you can retrieve, for instance, the second job or the first job or whatever, and get the output. So it's not lost just because you close down MATLAB and go into it again. It's still there. And now let's try and do this for the MATLAB script that's called add2. And the always one is still not running. I am just going to open another window also because I want to show you what's in this script. I'm going to log into Kebnekaise for that. I just need some place where I have the files located. Okay. So here I have the script here, add2m. And let's see. So this is what is inside of it. It's a very small MATLAB job script here. So what it does is adds two numbers. So you need to give it to input. The question is here now because I don't remember if I'm in the right directory. So I'm just going to exit here. And I also don't know if I actually have fetched these scripts here. So I'm going to go ahead and go and do this. That's right. I am on tetralit where I have a different username. So I'm in here and I have inside the exercises directory, it's from another one. I'm going to go ahead and you see here, I have placed all these exercises here and I'm going to copy the MATLAB one into my directory. Still being sleepy, I didn't sleep enough. I have the same username on all the centers except for on tetralit, so I need to remember what I'm called there. So now I got a directory MATLAB. I'm going to go into it. Inside that, I have all these small scripts here. And now I am going to start MATLAB again. And now I am in the right directory and I actually have access to add2.m. You could also just have set the path to where you have your files. But since I didn't have the files actually unpacked, I needed to do that. And I need to create a park cluster there. Let's see what it is set to. It's still set to what it should be. So that is good. And I'm now going to create my job. And I was going to use add2, this one I just showed you. And I expect one output. And I have some input that I need. And I'm just going to put in something here for it to add. And it's actually now sitting in a queue because there it started, as you can see. So now this job is started. I'm going to try and see how it's doing. It's running. Still running. Okay, it will take a little while, but when it finishes running, which it should very soon because it's a very short job. But I believe what happens is that I asked for 30 minutes. It's not going to use all the 30 minutes, but it's going to take a little while after it started running before it finishes, I think. Let's see how it looks. I'm going to log in again. And now I'm going to say SQ minus me. And there I can see that it has now finished. Yep, that was true. So I will do job fetch output. And that is the result of adding those two numbers together that I wrote. So it worked. That's great. So running parallel batch jobs, it's very similar to running serial jobs. You just need to specify a pool to use and MATLAB code that is parallelized. And easiest to show this is with an example. So making a pool of workers, again, you have the job handler and c.batch, and then you have your script or your function, any output you expect, and any input you're giving it. And then you also need to give pool and workers, how many workers. So I have a script called parallel example.m. If I give it the input 16 and create 4 workers and expect one output, it would look like this. Again, you can call the job handle anything. So let's try and run this. I am going to simply copy this and run it here on Tetralit. And let's see what happened. See, it is currently in the state of configuring the job. And let's see what the state is on MATLAB. And now it's running. And you can see here it is running. So you can keep an eye on it both places if you want to. And then when it's finished, you will be able to fetch the output much the same way as you did with the serial one. And this example, you can either download it here or you can find it in the exercises table. And I'm going to assume that you got those. They are located under here otherwise. But they are also on the clusters themselves, so you could copy them as I did. Let's see how the state is. Now it's still running. I'm going to continue because we are soon out of time. But when it finishes, just like I did with the serial job, I will fetch the output with j.fetchOutputs. And I'll just mention there's the par pools. And if you are starting a par pool, a parallel pool inside MATLAB, then you can simply run your code there. And what you would do is that you start the par pool with however many processes you want. And then you just run your example or whatever your script. And then that will run inside this pool. That is also started as a batch job. It is just that it's already started, and when it's already started, you can work at it as if you had an interactive job. So you run one script and then you run another, or you do some other commands inside of this pool, and that means that you are running it like you did an interactive job. So the last thing I'm going to mention is batch scripts containing MATLAB code. This is still queuing on Elvis. You can create MATLAB batch scripts and start them from the command line instead of from inside MATLAB, just the same way as you would run any other batch scripts. So that is not interactive in any way. You cannot make changes to it after it has started. but that can also be good because maybe it's a long job and you just want to send it off and then come back and check on it a day later or something. So let's look at an example of a serial batch job. And I have some examples for the different sites. So a batch job, if you haven't seen one of those before, first there is this line here where it tells the system that it's going to be run in a bash shell, because that is the only one that's compatible with the Slurm batch scheduler. So just put it there. And then you put your project number in UPPMAX. This is the one I'm using here, since this was tetralit. Let's take a look at that. So here you have this project ID, the account, and I have one tasks, and the CPUs per tasks is 1, so that means I'm getting 1 core here, and number of tasks per core is 1. I am setting all these 3 in order to make MATLAB not try anything funny. And I just ask for 15 minutes. I don't actually need that. It's probably going to take 10 at most. This is my Monte Carlo MATLAB job. And here I also set the error and the output files to different files. You don't need to do that, but it can be useful if you want to easily see what were the errors and what were the output, instead of maybe having them interleaved. If you set the names of the jobs, it's good to add this %j, because that means that it will have the job ID added in there, which means it will be different for each time it runs. Otherwise, it overwrites. You don't want that. And here I load this module that I also loaded on the command line. And then I run my MATLAB script this way. Again, I add the single comp thread and no Java, no display, and then -r and the script itself and the input I'm giving it. I'm also running time on it. You don't need to do that. I'm just doing it because I wanted to time the execution. And I then submit it. So I am first going to see if this is finished. It was. So I am going to see what the output was. It was not this one. It was for this handler. And you can see this is correct. And you also see that it knows there are 2 different job handlers, as it should. So let's exit MATLAB and then quickly try and submit this batch script. So you see this batch script is somewhere here, there, for tetralit. This one, it's the same as this one here. And I'm just going to submit it with sbatch and serial tetralit, like that. And you see here you get the job ID, and you can do sq --me, and you see it's running, and you can do scontrol show job and this job ID. So it runs, and let's see, it's still running. And it will run for maybe 10 minutes or something. So I'm not going to wait for that, but it should create output files that are named MATLAB and the job ID error and out. But it's going to run for probably 10 minutes before it finishes filling stuff into those. So we're not waiting for that now. But you should try it yourself. It should work on any of these systems here. And if you're on a different system, you need to make a small number of changes. mainly the name of the module for MATLAB, and also you need to change the project ID, and that probably is enough. I'm not going to say much about the parallel batch script, only to mention that you can of course also submit batch script for parallel, but here you need to be careful because MATLAB has a tendency to spawn too many threads when you are running a parallel MATLAB script. So this is an example of attempting to get this right. If it fails, then it might be better that you start the parallel ones from inside MATLAB, as I showed you that you could do. But there are some examples here for each of the centers where you can try and run it yourself. And of course, you can also do a GPU from inside MATLAB, and you handle that by adding it as the additional settings you set, and you do that from inside of MATLAB, the same way as we did with the account and with the wall time before here. So you set them the same way. But I'm not going to talk about that today. I'm going to talk about that on Friday on the GPUs. So what we talked about is the Slurm scheduler. It handles allocation, and it allocates compute or calculation nodes. Batch jobs, they run without interaction with the user. And they also do if you start them from inside MATLAB. But if you start a par pool, then you can work interactively. Batch scripts has one part with Slurm parameters that describes the allocation and the resources you're asking for, your project ID, and then the second part that contains loading the modules and the commands to the MATLAB script. And you can run MATLAB as a batch job or from inside a MATLAB, whether shell or GUI. And if there are inputs to your MATLAB script, you have to include them in batch because it runs without your input afterwards. And on most of the systems, you need to configure MATLAB before you submit the batch jobs. And this is so it knows some data about the cluster, so it knows how to run on that. Okay, we are now definitely over time.